So nuclear fission is breaking a nucleus into two smaller pieces. Nuclear fusion, we talked about fusion as being melting or putting two things together, like the chocolate chips fuse when you melt them, right? Nuclear fusion is combining two smaller nuclei into a larger one. That also involves a tremendous amount of energy. So both fission and fusion are highly exothermic. They form daughter nuclides that have greater binding energy per nucleon. So there's a tremendous amount of energy. Fusion is the energy source of the stars. So our sun is just constantly generating heat, right? Where does it get that energy? Nuclear reactions, fusion reactions in specific, things like combining helium and hydrogen nuclei together to form larger atoms. It's also the basis of the hydrogen bomb. So there's the atomic bomb, which uses fission, splitting of atoms. The hydrogen bomb uses fusion. The hydrogen bomb is up to 1,000 times more powerful than the atomic bomb. It's like, that's just huge, right? So in this hydrogen bomb, what we have is two different isotopes of hydrogen. This is deuterium and tritium. So deuterium is a hydrogen atom that has one neutron. A regular hydrogen atom has no neutrons. It just has a proton. So deuterium is named because the mass number is 2. Tritium has a mass number of 3 because it's got 2 neutrons. So if you combine these in the correct way, they will form an alpha particle, helium-4. Actually, it's not just an alpha particle. They do form an element, an atom, helium-4 and a neutron. So to get this started requires a really high temperature. And so to get the fusion bomb started, you use a fission bomb. But this is what's going on here. Tritium and deuterium come together and they form helium-4 and a neutron. So this would be really, really awesome as a power source because the waste products are much less and it generates so much more energy than fission does. Fusion is putting together, fission is taking apart. 10 times higher energy density than fission. Fewer side effects from waste and such. The problem is how to contain the fusion. So making a bomb is one thing. Tremendous amount of energy released, but that energy isn't very useful. How do we make this happen in a controlled situation? The temperatures required for this to happen are higher than any material can withstand. It will melt anything. So how do you put it in a box? You can't. So they're working with things like magnetic fields to contain it because you can't melt a magnetic field. It's not matter. So people are working on it, but so far not useful. Any questions about fusion? You should know the difference between them. Fusion is two small nuclei coming together to make one. Fission is one large one splitting apart to form two smaller ones.